Hey, what's up, guys? So today I want to share this very trivial question, and but maybe it's a little bit interesting that you can think a little bit. So the idea is that the question is that if there is a one perfect square in the arithmetic progressions and there are infinite many, we should assume that these arithmetic progressions are a subset of integer. So basically, what I'm saying is that if you have a plus d, a plus 2d, this kind of arithmetic progressions. If you find somewhere, if you find some guy here, it's perfect square. That means the m squared for some integer. Then you can find infinite of them, which are all perfect square. Okay. So you can pause the video, think a little bit. Okay. So the solving why this definitely is true, right? If you have some idea of the quadratic residue. Okay, if you have some idea of quadratic residue, then you know that that suppose you find m squared is a plus kd. Okay, so that means that you can write this to m squared a mod d. Okay, so obviously that you will guess that obviously from your knowledge that you will guess that this guy, right, should have like mod d kind of solution. So we will give you the infinite solution in principle. Right, but if you don't know this quadratic residue, then the idea is that you need to start from this equation and construct the next. Right, if I can start from here and then construct some other case, that I can prove that there are infinite of them. Okay, so proof idea is very simple. Let's say m squared is a plus kd. Okay, so what I need to do is very simple, right? I can just think a little bit. I can just do the m plus d squared. Okay, so these ideas come from this quadratic residue, right? So if I can do m plus d squared, and I claim that m plus d squared must be in the arithmetic progressions, the reason is the following. By the way, I can, without loss of generosity, I can assume m squared equals 0. Then I will get a plus kd plus 2md plus d squared, which is a plus d, k plus 2m plus d. Okay, so this guy must also be integer. Okay, and I can also assume kd or positive or negative is doesn't matter. Okay, so a plus d of something, so this guy must be in the arithmetic progressions, and must be like this guy must be the a perfect square. Okay, so this is proof. See you guys next videos.